I want us to graph y equals tangent theta. Okay? Just want us to graph y equals tangent theta. I won't require you to do anything funky with tangent, no extra numbers, no change of amplitude, because we don't have time to study it. I just want you to see where it comes from. And where it comes from is this. Remember, in geometry, we learned a phrase, so, ka, toa. Right? Exactly. Right. So, ka, toa. Sine, cosine, tangent. So let's focus on this tangent, because that's what we're doing here, right? Let's focus on this tangent. So tangent, the tangent equals, guys, what does the O stand for? The opposite side, OPP, over the adjacent, ADJ. Doesn't sound quite as good. Tangent equals the opposite over adjacent. Now, hold this for a second. Tangent equals opposite over adjacent. Now, what does sine equal here? Sine equals opposites, OPP, over, what does the H stand for? Hypotenuse. Okay? That's just a review from geometry. Now let me do something kind of interesting. Take this sine here, do a little division sign. Sine divided by cosine. Sine divided by cosine. So put another divide. If you divide by cosine here, you got to divide by cosine here. Right? But what does cosine equal, ladies and gentlemen? Cosine equals, what does the A stand for? Adjacent over the H stands for hypotenuse. Well, this looks terrible. It's a fraction over a fraction. But wait a second. Dividing by a fraction is the same as multiplying by its reciprocal. So let's just multiply by the reciprocal here. So hypotenuse over adjacent. Again, I'm not going to test you on this. I just want you to see where it comes from for next year. What's going to happen with these two hypotenuses? Right, it's just going to become 1. So we are left with sine over cosine equals opposites over what? Adjacent. Sine over cosine equals opposite over adjacent. Where else have we seen opposite over adjacent? Tangents. In other words, in geometry you learn this, right? If A equals B and B equals C, then A must equal C. What property is? Do you remember that property? It's not the symmetric, it's not the reflexive, it starts with a T. It is the, not tangent, it is the transitive. If A equals B and B equals C, therefore, tangent equals sine over cosine. Tangent equals sine over cosine. But guys, what letter does sine represent on our unit circle? What coordinate is that? Y over cosine, which is x. So tangent equals y over x. Tangent equals sine over cosine, y over x. Knowing that, we're ready to finally do our final graph of the year. So draw a unit circle here. You won't have to do anything beyond just this graph. -1, 0, 0, 1, 0, -1. Okay, we're graphing tangents. So now this graph is going to be a little bit different. I want you just to make it more centered, not shooting off to the right, more centered. Let's go ahead and label this pi over 2 and negative pi over 2. Pi over 2, negative pi over 2. Alright? And we'll label this pi and negative pi. Okay, so we're kind of centered more. You won't have to do anything except just recognize this graph and do the basics. Alright, let's think about this, guys. At each point, tangent, remember, tangent equals y over x. So let's think, guys, at 0, what is y over x? What is 0 over 1 going to give me? What's 0 divided by 1? 0. So we start at 0. 0 is 0. There we go. Now, let's go over to right here, halfway. This is pi over 4. This is pi over 4 radians. So go ahead and put it right here. This is pi over 4. At pi over 4, ladies and gentlemen, remember this is a 45, 45, 90 triangle. 45, 45, 90 triangle, pi over 4. Do you guys remember what the length of both of these legs is going to be? It's the square root of 2 over 2. They're both square root of 2 over 2. So if you divide y over x, what is this number over itself going to give you? What is any number divided by itself? 1. So at this value, you're going to equal 1. So pi over 4 equals 1. On the other hand, if you go negative, I'm just going to do positive and negative at the same time. If I go negative pi over 4, let's do negative pi over 4 right here, halfway in between. Negative pi over 4, that's going to give me almost the same thing. You're going to have square root of 2 over 2 and negative square root of 2 over 2. So it's almost the same number, except you've got a negative here. So when you divide them, what number is going to be left over? Negative 1. Negative 1. So it looks like a line. It's a lot more interesting than that, though. Watch what happens, guys, when you get up here to pi over 2. At pi over 2, what is 1 divided by 0? It's not 0. What's anything divided by 0? It's not 0. You can't divide it. What do you call something that you cannot do? It is undefined. So this is undefined. At pi over 2, it is undefined. You cannot divide by 0 here. So what you're going to put here is an asymptote. You cannot divide by 0. Same thing, if I try to go down here, negative pi over 2, or 3 pi over 2, positive, negative pi over 2, and you're trying to divide by 0, that's also undefined. So a pi over 2, negative pi over 2, you are undefined. Pi over 2, negative pi over 2, you are undefined. In fact, it's going to be just repeated every pi over 2, it's going to be asymptote, asymptote, asymptote. So let's go ahead right here, it's not going to be a line, it's going to be a swoop, and then getting really close, but never touching that asymptote. Same thing here, swoop downward, never touch the asymptote. It's just going to keep repeating that kind of pinwheel look. So if we go for pi here, put a dot at pi, he would shoot up this way. We're kind of off the picture here. He's going to shoot downward this way. Got room here. At negative pi, he's going to be shooting up this way, etc., etc., etc. You're going to keep having asymptotes here and here and here.